Hello and welcome. Last day of testing. We're gonna test the backend now. Nice. You also mean introduction to testing, then testing some React, and now we're gonna be testing some of the backend. So I want to start by telling you testing is really, really important. If you haven't been practicing testing since the first time that you saw it on the first introduction to testing, you should have been, and you should continue to practice from this day forward. It's going to save you a lot of pain. You are working with a language that has no protections for you as a developer. So if you want to save yourself some frustration and a lot of hours wasted chasing down bugs, start writing tests for every piece of code that you write, as long as you're in JavaScript. Okay. Some other languages will protect you from some errors. JavaScript will not. JavaScript will just find a way to always waste your time tracking down bugs that should have been detected by the tooling and the language. But how do you avoid that? You write tests. So you have been informed of, if you want to save yourself frustration and pain, write tests. Now, will your test be good? Of course not. It's something that you have to learn. Okay? You have to learn. No one is going to expect you that they're going to sit you in front of a piano and you're going to be Mozart. It takes a lot of work to get good at playing that piano before you are Mozart. Okay? So it's the same with testing, but you have to do it. By doing it and doing it and doing it, you will find the patterns that work depending on what you're trying to test. The hardest thing is always going to be what? What should I be testing? And then how am I going to test that thing? And this is where the tooling comes in. Depending on what language you're using, depending on the testing library you're using, the how is going to be different. But the what is always going to be the same, because the what depends on the system, not on the tooling, not on the language, not on the framework. You always have to identify what is the stuff that should not fail, because if it does, the system is not doing what it's supposed to do, and that's the stuff that you test. Okay, so let's go to the test on the back end. The test on the back end is going to have at least, I'm not sure, there are different types of tests, but I'm not sure where integration tests end and end-to-end tests begin. I mean, all the way at the end where you have, from front end to database, I could say this is definitely end-to-end. But depending on who you ask, integration tests, end-to-end tests, they're like, there's this place where there's a gray area there where you don't know. But what I'm saying is that when you're writing the testing for the backend, you have two types mainly, right? I'm gonna group them in those two. You are either writing unit tests, like we did yesterday, and that means just having pure functions that you just export and then you import and you test. That's what we did yesterday at the end of the lecture. And the other one is end-to-end-ish, integration-ish tests, where you are hitting an endpoint and you may even hit the database. Okay? So those are not unit tests. Those are not meant to be run every time you make changes to the code. Unit tests are meant to run every time you're making changes to the code that is tested. End-to-end integration are not, because they're slower. They are either hitting an endpoint and going over the network, hitting an API, or even hitting a database, or maybe hitting external services. So those tests are slower. They are normally run less frequently. Okay, even though you're gonna see me testing an endpoint here and running them, running them is because it's a lecture, right? But in practice, you're not gonna be making another change and running all the way to the database. It takes too long. It will slow you down. So normally those tests are run far apart from each other, not instantly. Unit tests, though, on the other hand, are meant to be run that way. So keep that in mind. I want to talk a little bit about theory first. TDD. Let's see if I can find a nice image here for TDD. Anyone will do. This will do. Perfect. It's probably an article. Go away. Here's the image. Okay. So there's this thing called test-driven development. And the idea here is, do you start by writing a test that failed? And then you write enough code to make that test pass. Then once the test passes, you look at your code, both your test and your production code, and you say, can I make this better now? Can I reorganize it better? And this is where the refactor phase comes in. Refactor means I'm going to change my code around without changing the functionality. And that is the basics of the TDD cycle. Okay? So that means that before I write any code, I have to have a test that says, this is the stuff that I plan to write. And this is why some people say this is test-driven development, but some people say this is also test-driven design, because as you're writing the test for a code that doesn't exist, you are envisioning or designing how that, let's say that you're building an object with a method, how would that look like? What is the name of that method? Is that going to be an object that has, two methods? Is that going to be an object that needs only one method that does two things? Like, you are designing what your resulting system is going to be. You're making decisions about the design. So TDD, test-driven development / design, it is a practice that for unit testing and for code that has a lot of logic is very, very popular, and I think it's useful. Don't take it to the extreme, and you no longer, you don't always get the chance to start from scratch with an empty editor and let's go build it. You may jump into a project that has a lot of code, but let's say that you are asked to add a feature or to fix a bug. Well, there are no tests. Probably that's why the bug is there. So there are no tests. So what do? Well, we agree that there is a bug and we know how the bug is going to be manifesting itself. So let me go write a test that shows the presence of that bug. And when I make that test pass, that means that I fixed the bug. But it also means that if that bug ever comes back, it's called a regression. If that bug ever shows up again, the test is going to catch it again. It's going to, the bug is back. So this is why it's important that even if it's an old code base that has no tests, you have to start as much as you can adding. You need to add a new feature, test-driven development with it. Add tests for that feature and implement it in a way that by the time it's done, it's got tests to guarantee that the functionality is there. So now that we agree, because we agree now that test is good and that we can use TDD or not, let's see what it means, or how do we test the backend? Well, let's say that I'm writing this endpoint, the one that says, I'm going to hit this endpoint and it's going to give me back an object that has an API property with a text up. But also it's going to give me a 200, okay? Not a 500, a 200. My system relies on this functionality. This is pretty simple, Luis. Yeah, I know, it's got to be simple so that we can concentrate on the testing portion, not on the functionality. But let's say that I'm a client and this is some important functionality for me. It's always I'm expecting that this is going to be called API, and I'm expecting that I'm going to get up back. I'm expecting that this is going to be an object. I'm expecting that I'm going to get a 200. I'm expecting that this is not XML. I'm expecting, or HTML. I'm expecting that this is going to be JSON. So how do I check? Well, I hit the endpoint. I spin up the server, hit the endpoint, and check the result visually. Okay. So that means that if I have, 500 endpoints, I have to go one by one, checking the endpoints, and maybe I have a post, and in that post, or maybe I have a get that I could pass query strings to. Then I would have to test every possible case with those query string, every possible combination to make sure that I always get the right response. This is how we test it. So automatically, we do the same thing. We automate that process of, I'm going to spin up a server, I'm going to hit the endpoint, and then I'm going to check what I got. Did I get a 200? Did I get some JSON? Did I get an object that has this API? So that's the stuff that we're going to write, but we're going to write it in JavaScript. So we need a way to run that server for the test, and we need a way to hit that endpoint, okay? So the library that we'll be using for the spinning up the server and to interact with it, making the requests and all that, and you can think of it as another HTTP client, just like Insomnia or Postman. It's just gonna, with the extra ability of spinning up the server too, but it's gonna let you make requests the same way that we're doing it with Insomnia, similar to that. And it's called Supertest. So npmjs.org, if you go and check Supertest, you're gonna see some examples in there. And this library, it's a little library could work with or without using jest. We are going to use jest with it so that we have the power of all the jest matchers. Okay, but it is possible to use this with any other testing framework, and it is possible to use it. Like if I want to check that is returning a 200, I could just use that expect. This expect though is part of the super test framework. It's not jest. It's not the one that you're right. This is a chainable method that the library provides. Without a framework, you could check for that. You could check the content length. Someone was asking, I don't understand what the content length test is. Yeah, it's just checking that when this is a header, like any other header, like content type. Okay, so this is just checking that you got 15 things. The size of that is 15 characters of the response. So whenever you send, this is a test that you could do. I'm sure there are cases. I've never ever been in a test like that, but I'm sure there are cases where what is important for you to make sure that you're getting the right size of the response. That's what it's doing. It's just checking that header, saying that the value of that header is this. And this is just checking that the content type has JSON in there by passing this regular expression. And this is checking that you're getting a 200. Pretty simple to do that. We're not going to do it this way, though. We're going to use that then. Somewhere in here, just an example with it. That goes to where's it? That there we go. This is what we're going to use. Instead of using expect and set, well, you could use set if you wanna set headers. For instance, let's say that you want to test an endpoint that needs authentication. You need the token. So what do? You hit the login with valid credentials, get that token back from the response, and then you make another request, and then you set the authorization header, passing in the token that you got. And now you could make that request, authenticated request, to that endpoint. So we're going to use, you could use, we're not going to see an example of that, but you can use that to set headers. If you need to pass data because you're testing a post, then you have the .send method. And in the .send method, you could pass things like that, but you can also pass like a simple object. There may be an example here of another, yeah, there it is. A simple object, JavaScript object, and it will be turned into JSON for you and passed to the API. So pretty simple to use. The only difference from all of the examples here is that we're going to concentrate on the assertions. We're going to use the assertions using the .then here. And then in here, we're going to write our jest expects. Okay. So let's go check. Let's go write a simple test. Again, we were testing that. Let's test. The first one is, am I getting a 200 okay instead of a 500 or 400? Let's go write that test. So we need that library. Let's go install it. npm I super test. Actually, we need jest too if it's not there. I don't know. It might be. I think it might be there. They might be there on your project. I'm still going to try to install it just in case. Super test and jest as dev dependencies. We also needed to make sure that jest is working node mode. You remember how to do that? How do I do that? Let me see if anybody remembers that. How to configure jest to run in node mode. Cool, I should have super test now. Let me stop the server. Okay, nobody remembers how to do that? Well, we go to the package.json. Again, this is one way of doing it, and we want to add that extra key for jest. And in here, it's going to be, I need to tell it what the test environment is going to be. I'm going to set that to be node. Okay, save that. And now we have jest configured to run the test in node style. Okay, excellent. Now, let's go look at the server. We already have a file here, server.spec. Remember that test.js or that spec.js is going to work either way. And of course, what we're trying to test here is our server.js, because server.js is where that endpoint is. Right? We have the endpoint, and we're going to be testing that server. It's got some endpoints in there. Those are the endpoints that we have available. This is the one that we want to hit. Okay. So we need the server, of course, because the library needs to run the server. The server is not running. It doesn't need to be running for you to run the test. So let's go bring it in. First, the library, right? So const super test. They have on the examples, they call it request. So if you want, we could just call it request, but just know that it's super test, right? So request, it's going to be equal to require, and then super test. Okay. Now we have the library, we call the request. So this is going to help us. I'm going to pass in my server, and it's gonna know how to spin up the server, and then I'm gonna make requests to it. So const our server is coming from require, and then in the same folder we have the server. Okay, it needs to know where the server is. And then we're gonna describe. I'm gonna say these are my server tests, right? Let's write a function so we don't think that it's only arrow function. It could be any type. You know, it could be also a regular function. Okay, and now in here I'm gonna add another describe, and this is gonna be for me get my get to slash. That's what I'm testing on this test here. Okay, cool. There we go. So now we have an area where I'm gonna be testing the server, and this is the get to slash. Now let's go and write a test. So it no, don't help me. It should return 200. Okay, that's what it should do. Okay, and then we write our assertion in here. So in here, in order for this test to run, I need to first, you know, run the server. Then I need to make, this is what I did, right? I ran the server, and then I opened up Insomnia, and I made, you know, make a get request to slash, okay? And then we need to see that the response, the HTTP code of the response is 200. Manually, we did that. That's what we did manually, right? We're gonna do the same thing, but automatically. The package.json, yeah, sure. The whole thing, here we go. There you go. So let's do that. Well, how do I run the server? Haha, the library is gonna do it for me. So I could say request, here's my server, and now he knows how to run it. Now the next one is I need to make a get request. Okay, excellent. I could say that get, and then decide the endpoint. So I wanna do a get to slash. So request the library over here, right? I'm gonna pass it to server, and I'm gonna make a get request, and then I'm gonna get a response. Okay, that response. I wanna make sure that the HTTP code of the response is 200. So I can write expect. What is that? The response dot, and I have a status here that's gonna check for the status code for me. And I could check that this is to be 500. Actually, I'm gonna make it 200 first. And I wanna show you something interesting that you saw this because I watched the videos of the testing because I was getting the, you know, I went into a WordPath, let's say, saying, hey, we need to introduce these testing concepts before we get to the backend. And then I was surprised with videos of, yes, that was introduced, but if you don't practice it, you lose it, right? So it's been such a long time that you probably forgot about all that. But it is important from now on. Now I want you to walk away with this. Maybe if you don't understand, I'm gonna throw a whole bunch of stuff at you. And I was telling your TL this morning, I know that you're not gonna remember all of this. You're not gonna understand a lot of it too on the first pass, just because it's a lot of information. But I want you to walk away with the idea is, I have to get better at testing. I have to continue practicing testing. I need to write tests even if they're wrong, even if they don't work, even if I'm testing the wrong thing. I don't care, right? I don't care that I'm not an expert yet. I'm still gonna write a test because I know that the way that I'm gonna get better is by writing more tests. So that is the goal of today. If you walk away knowing, hey, I remember that there is a library that you can use to test the backend, and I remember that you could test the endpoint. I remember that you could test all of my functions, all of my pure functions. And I have some code with some samples for that. But I definitely know that I should be testing every day. I should be writing tests every day until I get really good at it. Okay, that's your goal for today. Walking away with the urgency of I need to write tests because this is going to save me so much time and pain. Okay, cool. So I'm testing this, and you may not remember, but part of the things that you've seen is that when you're testing code that is asynchronous, Jest needs to know that the code is asynchronous. The way that it is now, Jest doesn't know. It just doesn't know that this code is going to be asynchronous. We have to tell it that the code is asynchronous in some way. There are 3 ways of doing that. We're going to see one. Okay, you have to tell it that. Shaking my head. It's like, no, yeah, I want to fight that fight and I lost it because, hey, look, this is the video. Watch. So walk away knowing that you need to test and practice testing. Now, we're going to see one way of telling Jess, hey, I want you to wait, because the problem is, watch, NPM, do we already have the testing script in this? I don't remember. Yeah, it's there, NPM test. So I'm going to say NPM run test to run my tests. Should be running now. Excellent. Delete this for now. All right, so it passed, right? It passed because it's returning at 200. Okay, so what if I test for 500? Because remember, we want to make sure that it can fail. Okay, we want to make sure. How do we know that this is passing? Because it is actually passing. So we're going to save that. It's going to run again, and it's going to be checking for 500. Oh! And it passes again. Okay, what's going on here? Now, if we did not do an effort to make it fail, to see it fail, we would have thought, yeah, we're good to go, even if the code is not working. So now this test is lying to us. It's totally lying to us. If you have it running and your fail, it doesn't look like mine. If it looked like mine, you would be getting the same response. The reason for that is that this is an asynchronous call that you're doing to the server, and Jest is not waiting. This test and this test are exactly the same. Exactly the same. There's no code in there. So what's going on is you have all this code, but it's not being executed. It's not this expect, it never runs. It just goes all the way down here, gets to the end, and then sees that return undefined and give you a passing test because there is no error thrown. There is no failure. Okay, so in this case, the absence of failure is a passing test. Shouldn't be. Should tell you, hey, this is an empty test. There's nothing there. But yeah. So the point is, I have to make sure that I tell Jess, you have to wait until the promise resolves, and then you're going to run your expectation. Simplest way is just returning this. So if you return the call to the server, now Jess knows that it needs to wait. And this is when you're going to get this. Okay? So go write it, make sure that it can fail, and then make it pass. Your job is to write that and let me know when you're good to go. Have to make sure that it can fail when you pass it at 500, when you're checking for 500. Excellent. Question shows up, people run to answer it on Slack. Very nice. All right, everybody's good to go. Again, only thing that we have done here is with the same steps that we would have used manually. Always think of it that way. Okay, how would I test this? Again, you're gonna have the question, the harder question to answer is, what should I be testing? So I'm gonna tell you, test 3 things for each endpoint and begin there and then go from there. So the first one is you wanna make sure, because if you're trying to do a post to an endpoint and you pass it invalid data, it should give you back some kind of error. It's not going to be a 201 saying, hey, you're good to go. But if you pass it good data, then it should return back a 201 telling you. So you could check for, if I pass invalid data, do I get a 400? If I pass, and again, you're testing your API, the functionality of your API. Given that my endpoint receives bad data, am I returning out is my logic good to return the right HTTP status code? So that's one thing that we can test. The endpoint returns the correct HTTP status code based on input, okay? That's one test. The other one is the endpoint returns JSON always, right? Because it is a JSON API. Could be JSON, maybe you're writing an API that returns XML, so you check that it's returning the right format, right? Let's say that the right data format. In our case, JSON in our case. But there are other formats that you may need to work in there. The other one is that the endpoint returns the right data based on input, and the right data, let's say in the body, like I could check the body, and this is going to be again based on the input. So those are 3 things that you can test. Even if you only test the first 2, even if you only test the first one, you have something. You're testing something, right? It's better than if you were testing nothing. But you can go a little deeper, okay, slowly. Now, 200. And then again, the tests are going to look the same, always, right? You're going to return a call to the server, and then you do your operation, whether a get, a post, a put, a delete. They're all supported there. And then you're going to get a response back on the server. And that response has a few properties that you can check. We are just checking the status code, but maybe I want to check now that I'm getting JSON, okay? The format, the type of the response, and that is a header. And you're going to be learning more about header as you test a little more. But the header that defines, you remember how, let me see if anybody remembers. What is the header to ask the client to store a cookie? Do you remember what that header is? Yeah, the set cookie header, exactly, right? And it is set cookie header. Well, there are other headers, okay? And remember, what is the use of headers? Oh, that is an important question. Let me add this one. What is the use of headers? What do you use headers for? Okay, let's see, some ideas. What are the headers for? Communication between the backend and front end. Yes. There's no body on get requests. Well, yes, but it's more than that, right? Communicate info when there's no body. Well, whether there is body or not, you're still sending headers. There could be a body. When you do post and put, there's a body. You still send headers though. Okay. So if you thought that the use of the header is just to pass data when there is no body, that's not what it is. It's more powerful than that. think about the set cookie header. The set cookie header is sent back from the server to the client. And whenever you send a response, there's always a body coming back. You're going to always use the body and send data. Okay. So the headers are a way for the server and the client to communicate information, to agree on some things. So they talk to each other that way. So one of the things that they remember the error when someone was making a post, and even though they had the body here as JSON, there was a header that is supposed to be content type application JSON and was unchecked. You remember that error yesterday? How did we fix it? By adding that header. Why? And at that point, I told you, this is how the client tells the server, I am sending you JSON. So the headers are a way for the client and the server to communicate intention and to communicate things to each other. Just by not having that content type application JSON header there on the Insomnia, the server did not know that it was JSON, even though it was ready to parse JSON, but it didn't know what it was getting. So it did not try to parse it as JSON. It didn't know what it was. So headers are important. One of the headers, going back, right, the content type, could go from the client to the server, like we saw in the example of someone running into that error because the header was not there, but it's also part of the response. The server can tell the client, hey, I'm sending you JSON. So we could check for that, right? So let's go and copy this code, save some time because we have some of the code in there is going to be similar. And notice how we were doing this in isolation. Remember, always to return a request to a server. I'm going to do a get, check the response, but instead of the status code, now I'm going to check that the type, the content type, right? You could also check for the actual header, but in this case, I could just say type to be, and instead of to be, well, you could say to be and pass it like this, application/JSON. But here's the thing. Sometimes you may have also something like application slash, XJSON or JSONX or some other type that is also JSON. So this is why having a to be is probably not a good idea. It's more like I want something that has JSON in there. So it would be more like a regular expression. I'd like to make it always case insensitive by adding that there and say, I want to see JSON somewhere in there. Okay. Now this cannot be to be anymore. It's going to be to match because I'm now passing a regular expression. Okay. So I'm going to say, I want this thing to send me some XML. XML is another way to transfer data like JSON. Looks like HTML. And now it's telling me, no, it failed. I know, again, I know that it can fail. Okay, I know that it can fail, and I know that it's sending me the right thing. So let's go and make it now. All right, I know that it can fail. Now, if it passes, I can sure that, yeah, it's passing because it's passing. Okay, cool. So now we have two things that we can check. Of course, JSON formatted response. Okay, excellent. So that's the second one. Let's get rid of all this extra code there that is not important anymore. Now, another thing that we could check is, remember that we were looking at the response here, and we said, well, it's got to have this property called API. Maybe what you're looking for is that there is a property in the body that says whether it was successful or not. Like you have to make sure that that's always there because the client depends on it. Let's say that my client depended on having that API with a message of up in there. So we could check for that, right? I'm going to write this, and then I'm going to have you write both. Again, let's borrow some code. I'm not copying, I'm just borrowing it. I'm going to do a get to the same place. I got the response, but this time I'm going to check for the body, right? That this is the body of the response. So it turns out that it's a property that is going to give me back an object with the body. So now I could say, well, I want to make sure that the body, let me take this opportunity to show you something. To be this API up. Okay, and it fails. It fails because even though we got the right response, API up, it still fails. Some of you already know what this is. Will you please tell me why did it fail? If you know. Why did it fail? Even though we can see that the response is actually returning API up. Okay, let's say, who knows? Who knows? Haha, yeah, because this is comparing using to be, and to be is checking for the references, and this is a totally different object from whatever I get back. So how can I fix it? Well, there is another matcher for that. So what other matcher can we use? Any ideas? And if you didn't know this, it's okay, you're learning it now. There's another matcher that we can use. Yes, we could use the to strict equal and to equal, right? This is shorter, so I'm going to say to equal. And what the to equal is doing is it's going to check all of the properties inside of the object and the values. So it's going to check not by the reference that is the same object in memory, but that is got the same data in it. So if we save that now, that should pass. There you go. Another way that we could have written this test without having to deal with the to equal is to say the res.body.up to, API, sorry, API to be up, right? And then we just test for the value over a single property. That means you don't always have to force, because if this test only cares that a particular property is there with a particular value, there is no reason for you to force the applicant, your code to go and check all of the properties of the object. You may have 20 properties in there and you only care about one, so you can check directly for that one. I want to check that the API is there and then that this is the value. Both cases test the same thing. Your turn. Go write those 3 tests, and now you have 3 very simple sample tests that you can run against your endpoint. Okay, you could check for information on the body, you can check for the type, you could check for the status code. And let me know when you're good to go. And this is going to be should return. Okay. Very explicit, so that when I read this, I'm reading the documentation of how the system, how this endpoint should work. It's telling me exactly what I can expect out of that. Very important. It's like having good commit messages. Very important that the description of your test is telling you exactly what you're testing. It's harder. It's hard to do. All right, looks like everybody's good to go on this one. So let's take 5 minutes, and then we come back and do a little more. See you in 5. All right, so let me show you a couple of things. On the package.json, when we run the test, we are using this magical package. Did you notice that? You notice there was a magical package in there? We haven't seen that before. What this package is going to let me do is I can set for only this command. I could set this environment variable to any value that I want. So basically what I'm saying is when I run the test command, I want to set an environment variable called db_env to be testing. Now, is that happening really? Let's go check. Let's go check if that's happening. I'm going to write a test it here. I'm just going to say should set environment. Let's do it environment. Let's do it with the DB environment to testing. Okay. Right. So I'm gonna write a test that's gonna check that for me. So expect, if this is working correctly, that the process.env.db underscore env has a value of testing. That's what it should be. Let's make it fail. Development. Is it set to development? And it should fail, right? It's telling me, no, no. When you run the test, this environment is being set to testing. So this test for my server is always going to check. It's always going to tell me whether I have testing. Yeah, testing. It's going to tell me if at every point in time I'm running my test and I'm using a different environment other than testing. Okay. Now, why do I want to have my test to run in the testing environment instead of, let's say, the development environment? Ah, glad you asked. Okay. Are we clear of what's going on here? What is this little package doing for me? Is that clear? No. Okay. So let's see something else in action. Let's see if we can clarify it a little bit. So in here I have this get, and it's just returning API up. I'm gonna add another property in here. That's gonna make my test fail, by the way. I'm gonna call it environment. I'm gonna say this is process.env dot no, not no, but db underscore env. And now I'm gonna run the server actually. And I remember that I have a test that is checking for particular body. So let me just comment this part. Because now we don't care about both properties, we only care about the API property, so it should pass. So in here, I'm gonna do npm run server. I'm gonna hit that /endpoint, and I should be getting back, oh, look at that. I should be getting back that environment, but it's not set up. There is no value for it, right? And the reason there is no value for it is because we're not setting it when we do npm run server. When we do npm run server, we're just running it with nodemon. So this value, this db underscore env, does not exist on the environment. Okay? But when we use npm run test instead, then it's going to exist on the environment because we are using it. So let me show you what I mean. I could take now that piece of code right here, stick it in front of this, and say, I want to set this environment to be dev, okay? See, the difference is I am changing the way that I execute using server now. When I do npm run server, first it's going to run cross env, and it's going to set this thing on the environment, and it's going to set it to a value of dev. So if we run it again, I stop the server, okay? I had to stop the server so that when I run it again, it reads this command one more time. So now that we go in here and we do send, we should see that, well, the server should be running. Testing cross mdb, no, something else. I broke something. What? Oh, this is nodemon. Well, that should be fine. db underscore cross m. Did I break something? I don't understand what oh, the problem is an environment. If you don't understand what the environment is, it's probably a good idea to go back and review from day 4 forwards, because we mentioned that along the way. I can explain it now, but it's going to be really simple. Like, an environment is where the application is running, and we can set values in it. When we deployed, we saw that we can read information from the environment. We had this thing called index, in the index.js, we have this .env, and that's going to give us the ability to read values from the environment. Okay. And we explained at length a development environment and a production environment and how we can set variables in there. So cross env, what is, we tested using .env files and all that. So I would say do a review of that. But for now, know that there are some values that in your application we can access by using process.env, like this value db_env, that could be set in different ways. Let me bring this back because this broke something somehow. I don't know why. Probably none doesn't like it. Okay. So this is already set for you to set a value on your environment that is testing. So we can use that. And the way that we use that is in our db.config, we are reading this value. We're making our configuration now dynamic based on the value that we have on the environment. So on the package.json, we set this value to be testing only when we run the testing command. Everywhere else is going to run without this value on the environment. Okay. If we don't have it, if we run it without it, then we want to set development by default to grab the configuration from the Connects file. Now, this is all coming together now. Right? We have the dynamic configuration that we saw before. But on our Connects file, we have another key. We don't have the production because we're not deploying to Heroku, but we do have the testing key. So we have a library, we have a configuration for a database called Hobbits. This is a stuff that we use when we use development. So when we run the server, normally like that, when we do this, we're looking at the Hobbits. Did we fix this error? Yes, we're looking at the Hobbits that we have on the Hobbits.db3. Okay, we're reading this database. But when we run the tests, though, we're not hitting this database. For the test, we're hitting the test database. And we have both. We have a database that we have now for testing, and we have a database that we use for development. So what you're seeing here is that you can dynamically switch to a testing database when running the test by using that little library there. Cool. Of course, this depends on you remembering what we talked about. We have talked about the environment. Okay, now that we established that, we know that we have a database that we're running for testing. And if you use this as an example, you can wire it up. Have a test database that you use to run your tests. This is important because if you were testing the code on the database, and let's say that you want to test, how will you test that you're inserting something into a database and you can delete something from the database? Well, you insert it and you check that the database has it. You delete it and you check that the database doesn't have it. You could do that against your development database, but that means that you're going to have to be inserting and messing around with your development database. But if you have a dedicated testing database, you can now wipe it out, no problem. You could take a table and just truncate the whole table, and no problem, because it's just for testing purposes. Cool. So it's really cool to be able to have an empty, clean database every time you run the test, so you could run your operations on it. First, it's going to be faster because it's not going to be growing as you write more tests and run the tests to insert data. You're always cleaning it. It's always a clean database. But also, it's going to give you some predictability. You can now check and say, well, okay, the table is empty. I know that it's empty. I'm going to check that it's empty because I know that I'm cleaning it before I run my test. So the table is empty. I insert 2 records. I can check that I have 2 records in there. They got inserted. Cool. So are testing and development used because they are self-descripting industry standard, or does string correspond to something within the NPM configuration? No, it's more the industry. We tend to call the environment that we work on development, and testing whenever we need to test, in production whenever we need to deploy something so that people use it. We pick those as an industry, but they're not a standard. You don't have to use those. You can use test. In fact, some people use dev and test instead, and prod, just because they're shorter. You could do 1 and 2. They're not very descriptive though, so it may be confusing when you have 4 environments. Now, if you have, you know, dev, test, staging, and production, those are a little more descriptive. So I will go with descriptive names. So why am I showing you this? Well, because if we know that we can pick the configuration for testing, and we can, during the test, target only the test database, now we have the flexibility to clean it up and break it and rebuild it and do whatever we want with it, okay? So let's go write, let's go use that TDD thing to write a couple of tests, but now we're gonna test our models. So we are going to, instead of going to the server and just hitting the post endpoint, which is something that you could do, we're not gonna do that. Instead, we're gonna go directly and test our models. So we have the Hobbits, we have this model, Hobbits model file down here, and we also have the spec for it. I'm gonna keep this down here so you have a visual of it. So there is an insert function. Look at it right there, this insert function. It happens to be async, but you can ignore that. The point is that this is going to insert. Actually, I'm gonna remove this async just to not make it confusing. It's just simple insert function now, like the one that you have seen. I'm gonna write a couple of tests to make sure that this is working. Again, I am testing my data access layer. I don't care that this is being used from Express. I could switch to another framework and this should not be affected. So if my inserting to the data works and I have tests that guarantee that work, I could switch whatever I want on the other part of the application because this is separate. This is just dealing with the database. So I don't need to go and make requests to endpoints on any of that. All I need is this file, okay? And we are exporting this insert function as part of this object. So let's go and bring it in. I'm gonna say const. And of course, I like the structure in this, so type less. I'm gonna grab the insert out of the Hobbits model. It's almost like a unit test, but it's not because it's hitting the database. It's actually going to be hitting a database. If you're doing that over the network, that may be a slow operation. So again, even though you see me like write a test and test it, write a test and test it, this is something that normally runs as part of the process of deployment, or maybe a couple of times a day, or maybe when you do commits to your repository, some automated process runs all of those integration or end-to-end tests. I don't know the difference, you know, right there in the middle. It runs those tests there. This is not a unit test, okay? Unit tests would not be making side effects and making calls over the network to a database or to anything. It would be a self-contained, pure test that is not relying on anything from outside, okay? So we agree that it's not a unit test, and we agree that it's going to be slower because of that, okay? Doing side effects. So I'm going to describe what I'm doing. What I'm doing is I'm going to be testing the Hobbits model. Okay. And then in here, I'm going to be testing the insert function. I'm going to have another describe. I like organizing my test that way. Okay, you can do it any way you want. Insert, excellent. And now in here, we're going to write some tests because we later maybe I'm going to write other tests for the other methods in there. So notice that even though the function happens to be in there, it's returning null. So it's not doing anything. We haven't done the implementation of that function. So this is basically almost TDD. If I remove the function, I'm just going to get an error saying there is no insert function. So I just bypass that. I just return null. So let's go write a test here that says it should insert a Hobbit. That's the whole point of this test. And again, Visual Studio Code is really helping me here by breaking all my code. Function. Excellent. So let's add some vertical space here, even though we don't need it. Just make it a little more, you know, like so. Separate it a little more. Vertical space is good. So here we go. How do I know? How would I know if I was doing this manually? How would I know? What would you do if you were doing it manually? Let me ask that question. Let's see. What do we get? What would you do? How to test and insert manually. And then we're going to see if we can automate that same process. How to automate and insert manually. There's a thread in there. That code says that it's checking for the rest status type. It's not status type, it's type, lowercase type. All right, let's see, how can I test this manually? So some of the ideas that we have is go to Insomnia, make a post request to Hobbits. Yeah, but I'm not going to Insomnia. Let's say that I'm executing this from the command line to run that insert. Okay, I don't want to involve a post, because what if the post is the stuff that's failing? I want to exercise only this code. So no Insomnia, no post. There's no framework. There's no express. There's nothing. It's just this library, this JavaScript library. When I can call that insert function. So what do we do? Okay, so add a Hobbit, and then I see that it says check response from promise resolution. How do I know that it got inserted though? So again, insert some values and check with the get. Again, I'm involved in the framework now. I'm involved in something that has nothing to do with the database. I want to isolate that. I want to check my library. What if the get is the one that's failing? And now my test fails for the wrong reason, not because I don't have a problem, because I have a problem with the database. So insert a Hobbit, right? So we insert a Hobbit, and then, check if it was inserted into the database. And maybe somehow, right? So we could use SQLite Studio. We could use any tool that is going to let me look inside the database. So I want to look inside the database and see that the Hobbit is there, okay? Exactly, right? So we insert the Hobbit and we check that it was inserted into the database. So we need to see inside of the database. Now, we're not going to spin up SQLite Studio to do that. Instead, we have a way to run queries against the database from JavaScript. What can I use for that? What can I use? What could we use to run queries directly against the database from JavaScript, from my API? How can I do that after I do the insert? Connects, exactly, right. So I could just use connects. Why? I don't have to test connects because I'm going to trust that the writers of the library wrote tests for that. So what I need is I need to insert a Hobbit through the insert method, and then I need to go directly to the database using connects. Okay. So I don't want to trust that I don't want to check the get all, because this needs to have some tests. Instead, I'm going to go directly to the database through connects. So we need connects. So let's go bring it in. And we don't really want connects per se. We want to have the connects connection that we already have configured. And we have that inside of db.config. So I'm going to say const, my connection to the database is on require. Let's get out of here, go into the data, dbconfig.js. This is my configured, because now this is respecting that I am on the testing environment, and it's going to connect me to my testing database. So now I have a way to quickly go and see the content of the database without having to spin up SQLite Studio. So let's go do that. Let's go and insert the hobbit. How can I do that? Well, I have the insert method in here, so I could call that insert, and this is going to take a hobbit. So the hobbit has, I think it has a name. Sorry, let me go check in the migrations right away. Yeah, name. It's got a name, and that's it. Cool. So we can pass it a name of Sam. Okay, that's our hobbit. Okay, insert Sam. And then, because this is going to return a promise, hopefully, then I'm going to get some kind of response. Now, we can now make a decision here because we haven't written the implementation of this. Do we want to return what? What is it that we want to return back when we do the insert? We could choose. Let's say that I'm going to assume that I'm going to implement this insert, that when I pass some data, I'm going to get back the hobbit. I'm going to get back the hobbit that was inserted. So let's say this is going to be my hobbit coming back. And then, all right, so I have a hobbit and I insert it and I got the hobbit back. What can I do in order to test that it's in there? How can I go and check that? Well, we said that we could check that it was inserted. So in here, I could go and say, and this is, again, I know that you haven't worked, some of you have not worked with async and await, but this is where async and await looks pretty nice here because you don't have all those nested thens. Okay, so I'm gonna write it once with async and await, and if it's too confusing, then we go and do all the crazy nesting of the thens. Okay, but I'm gonna show you how much cleaner this is without all of the, because now I have to go and make a call to check and then another then, and it's gonna be a whole bunch of nested crazy. But just by making this test function async, now I got access to this beautiful await. So I could say await on this insert. Okay, like so. So now we no longer need this nested then in here. That goes away. Okay, together with some other nested then that I was about to write. So we insert the hobbit that was inserted, and now I could check. Now I could say await db, look at the hobbits table, that's the name of the table in there. Okay, and I could capture that response, say const the hobbits is equal to that. Okay, not then. I would have to go another then again to get access to those hobbits. So beautiful. I insert the hobbit, and now I'm gonna read it, and now I'm gonna do the check. Okay, because now I have the hobbits that are on the table right now, and I'm gonna say expect. Okay, that, and if you look at the code down here, you could use this get all, but I don't want to trust it. I want to go directly to the database. So instead, this is why we're using the connects configuration instead of using the method. Okay, I'm trusting that connects people tested their stuff instead of me going through that, because this could possibly not be implemented yet. So I don't want to have this test depending on something that may have not been implemented yet. Okay, so I'm going to expect that the hobbits, this should be an array that comes back, to have length of 1. That's what I expect. That's my test right there. So again, I insert the hobbit. Okay, and now I'm going to check that the hobbit was inserted in the database by reading the hobbits from the database, and then checking that there's only one in there. It's an empty database. That's what I'm assuming, right? Then we run it. Ooh. To have length of, oof. Now, I really wanted to get an array, an empty array, but it's giving me nothing back. It's 0. Okay, there's a reason for that, right? We haven't implemented the insert. So there's nothing coming back. So we have to implement it, right? This is the whole idea of TDD. Now my test is failing. Now I need to go make a pass. So what if I do this? Return an array. I'm not going to do that, but you could just return a promise that resolves. Like you could do something like this, like promise that resolve, and then pass it an array that has one element in there. Save that, because what we are checking is, oh, that did not return. Oh, this is the update. No, sorry. I definitely want to do that on the insert, not on the update. And some TDD people are going to tell you this should be good enough. Return promise. What this promise that resolve with an array of one. Oh, no, that's not going to work. The reason it's not going to work is because this is returning something, but I'm checking directly to the database. See? So I have to actually try to do an insert to make it pass. So let's go try it. How can we do that? We have a db in here, so we could say db.insert, right? And we could pass it the table here instead of having into. We could say db hobbits, and then I want to insert there. The alternative would have been to do into here. It's the same. Into and then pass the hobbit that is given here, and then that should be good enough. Of course, every time we do an insert, we probably want to get that ID. This is not going to work though. I mean, it's going to work. It should work because we are having the insert, but we're not checking the hobbit, right? But the test should pass. Okay. Ignore this. Remember that from the first time we talked about it. This is not an error. This is just telling me that that ID here is not supported by SQLite. That's fine. It's going to go away when you go to another system other than SQLite. Okay. So it's passing. It actually passes now. Now, is that true? Well, insert a hobbit into the database. Save that. We run the test again, and now it fails. So it passed, and then it failed. Why? So why did it fail the second time? Why? Because the original insert is still there. Yep, we have that problem now. And the problem is that when we run the test, I make the change, save, and it ran the test again. So the second time the test ran, it ran the insert again. So we have two SAMs inside of the database now. Okay? And that is a problem. That means that every time I run my test, that data is going to get inserted. So what we need is a way to guarantee that that table, the Hobbits table, gets cleaned out before any of the tests run. Turns out, let's go up here. Turns out that Jest has just the thing for that. It's got a set of global methods. Let me show you real quick what they are. Go to the documentation. There is a, what is it? Set up and tear down right here. So this link that says set up and tear down, it's going to give you an explanation that is a little more detailed. But the point is that you get 4 things that you could check for. Let me make this a little bigger. You have the before each, after each, and you have the before all and after all. You see them right here? Okay. Now, before each is going to run before each test. After each is going to run after each test. And the before all is going to run at the beginning, before all the tests, and then it runs, so it runs once and then runs all the tests. And then after all, it's going to wait until all the tests run and then run it. What should we pick? Let me let you tell me. What should we pick? Out of those 4, okay, these are the choices. Should we write after all? After each? Before all? Before each? Okay, let's organize this. Before all, before each, after all. Pick a line, 7, 8, 9, or 10. Okay, let's see. Let's see what we have on that thread there. Before each, before each, before each. Yeah, I agree. I think before each is the right one, right? Because if I run it only once and I have multiple tests, I'm having the same problem. The second test that runs might be doing another insert. So I want to make sure that before each test runs, the table is empty. So not before all. And I don't want it after, because there may be some garbage that was there and I might run tests without garbage in there. So I don't want it after. So it's got to be before each. So inside this before each, we're gonna clean the table. Do you remember, another question? Okay, I'm peeking into your brain now to help me with this. Do you remember what is the command to clean a table and reset the IDs, just in case we need to reset them? Do you remember what that is? Do you remember? Okay, it looks like everybody remembers. There's like a whole bunch of people there. Truncate, exactly, right? So the way that before each works is I could pass it a function in here. Now, when you're dealing with the database, though, that's going to be an asynchronous operation. So you could, you know, wrap that and do the then. But the easiest way, for sure, to handle that is just passing an async function in here. And now, what this is doing is it's telling just, hey, this is going to be something asynchronous in here. Wait for that. Wait for it before before everything, wait for everything to be ready before you continue to run the test. So I'm just saying, wait until this is done and then go ahead and run the test, okay? And then inside of this function, this is what I call my truncate. Since I'm using async, it's beautiful because now I can use the beautiful await and say await on the database, go to the hobbits, and truncate it. And by virtue of having this async, I mean, this could be a function and you could just return this. It will work the same. But if you come back later, as you add more stuff, you may have more other things that you want to do before each test. So this is now setting you up in a beautiful way so that you could use synchronous and asynchronous operation inside this function, and they're going to be like a one-liner instead of having crazy nesting. So it's pretty nice, okay? So even if you were not using async and wait for other things, when you're writing tests, they really clean up your code. Cool. So now this is guaranteeing, even if I go and change this again and run the tests, save, it should work. The same test still passes, right? Because now before this ran, database was truncated. Always the table was truncated, that one table. Cool. Even if it works without async, oh, that would be nice. That means that they're smart enough now to do that. I'm still gonna keep the async in there. So if it works without it, even better. But keep the async just in case you need to do other operations later. Okay, it's not hurting at all. Now this is great, but what if my implementation, instead of having the insert hobbit, somehow is doing this? Name Frodo. Is that gonna pass? Of course it's passing. Okay. Now, is this code really doing what we think it's doing? Is it inserting the hobbit that I gave it? Not at all, right? So I want to make sure that the hobbit that you're inserting is the hobbit that I think you're inserting, right? So I'm gonna do this, and I'm gonna say it should insert the provided hobbit, not any hobbit. It's the provided hobbit that I want you to see inserting there. So if I give you Sam, I want to make sure that when that comes back, I see Sam in there. Okay. So this is where things start to getting interesting. I could rely on grabbing the first element because I know that it was empty and it's the first element. So if I have hobbits, I could grab that first element from there on that hobbits array that gets back. And instead of checking the have lens, I could say that the name of that to be Sam. Okay, we could do that. It should fail, right? Because now we know that my implementation is always inserting Frodo. I pass it Sam, but it's inserting Frodo. And it doesn't matter what I do. If I give a gaffer, save that, I'm still gonna get Frodo back. My implementation is wrong. My test is telling me that my implementation is wrong. So that's one way of doing it. The other way of doing it is I could have my insert now return the Hobbit that just got inserted. We could do that. Okay. So your choice. You could change the implementation, or you could just rely that, hey, you're inserting only one. What if I insert both, right? I could insert both Sam and Gaffer. Insert one and then insert the other. So I could check that 0 is going to be Sam, and then the second one is going to be Gaffer. Again, but also I could check that now the length of this is actually 2. So the length, I'm going to make sure that it can fail. Okay, it fails, telling me, nope, it's 2. So let's make it pass. 2, it passes, great. Now I could say the first one is Sam's and the second one is Gaffer's. Okay, it's got to fail on Sam's. Excellent. Right? Of course, I have to fix my implementation down here and say, nope, it's the Hobbit. Save that. All right, it's not Sam's, it's Sam. Excellent. And then it should fail on the second one. And I'm seeing it fail, right? It's Gaffer's, but it should be Gaffer. Save that. Excellent. Cool. So this test now gives me a little more, yeah, it makes me feel a little better, because I know that in fact I'm inserting the Hobbit that I'm passing it. Okay. Cool. Now your turn to go and implement this. Okay. It feels like I'm going too fast, but I haven't really done anything new. I'm just inserting something, reading it the same way. I'm not, the new information that I'm bringing in here is that I'm checking the name instead of checking just the length. That's the only new information. There's nothing else. So don't feel overwhelmed. There's nothing new other than I'm checking the property now instead. Okay, so go ahead and add it. Just making sure that my code is inserting the hobby that I'm giving it. The only thing that I is on the server test, I commented the code that had the to equal. Because when I was trying to explain the environment thing, I had to change that. That's the only change that I made so far. Server spec, I commented out this test right here, the to equal test. The rest are still the same. These are the two tests that you're working on. Can you use await? Nope. This is why it's called async and await. The function has to be defined as async in order to use await in there. So if it was me and I'm inserting and Frodo is overriding, what would I go check? What can I go check if I see Frodo? Frodo is overriding. Where can I go check what's going on? Is it inside the test? So this is telling me when I'm running my test that Frodo is the one that's being inserted. Where can I go check? Of course, right? So you would go inside of the model where the insert is happening to see why are you inserting Frodo, right? And then fix it, fix the code. Why did you just tell me, Luis? No, I want you to get into the process of troubleshooting, okay? Very important. Here's the thing with this lecture, with the testing. There are quite a few things that we write up and then we write and you see me like moving super fast. But at the end of the day, I want you to walk away thinking, how would I test it manually? Because you know how to test it manually. You write your code and you spin up Insomnia, or if it's on the database and you were testing just the insert of the database, you insert something in the database, you check that it is there. The new thing that I'm showing you here is because it's a lot simpler to read is using async in a way. Because you don't have that nesting, because then it's going to look a little more, it's just uglier. The code is harder to navigate that way. Because now with async in a way, you can think of discrete operations that you're doing one at a time. And you say, okay, I need to insert something, boom, one line, insert, no need to then and go and write code inside of the then. There's no misdirection. Okay, I insert, now I check. Okay, and we said that we're going to read directly from the database. We don't want to trust our code because at this point we may not have a way to read using our model to read the database. So we're going to read directly from the database using connects, and then we check. We're going to get something back, and then we check for that. Like in this test, at least we know that one record was inserted. Is that enough for me to feel good about it? Maybe not. Now in this one though, now I know that the first record that I inserted is Sam. If I change the order of this and save it, it breaks. Well, it should have broken up here because I'm testing at the same time. I'm testing that I'm inserting the records one at a time. They are in the right order, but also we have this, yeah, the returning, again, this, ignore that, that's console warning. But then we know that we insert the Sam and Gaffer, and the Sam and Gaffer are in there by checking directly in the database. Okay. It's not complicated. It's just the same thing that we would do manually. Now this one though is saying that it should return the insert the Hobbit. Now this is failing, right? Because I'm grabbing the Hobbit, calling insert, and I'm grabbing the response. And the response that I'm getting back is actually not what I expected. I expected that I was going to have an object that has a name in it, and that the name is going to be Sam. So apparently, the object that I get back does not have a name in it. It does not. And the reason for that is, if you go look at the implementation, is on the Hobbits model, what are we returning back? What does this return? Let's see. What does the dot insert returns? Do you remember? Because that would be the answer of why. By the way, testing is addicting, just so you know. Once you start writing code with test, every time you have to deal with a code base that have no test, you feel like you're driving without a seatbelt. It's just weird. Okay. Yeah, so you get an array. You don't get an object with a name, you get an array, and the first element of that array is the ID of the last record that you inserted. So if you insert 1 million records, you get the last ID. That's what you get, an array. So this, of course it's undefined. There's no name on that array. So we need to fix this, okay? Now we're making a decision that I want my code to return the inserted Hobbit. And I express that as a test. And I check that, in fact, it's not doing that. And now I'm going to go and implement that. So instead of just this, I'm going to say, and then after you do that, I would like, you know, I know that I'm going to get the IDs in there. It's going to be an array of IDs. So it's going to be like that, right? I grab the ID out of there. I'm going to return, actually, db hobbits dot where. Then I'm going to pass the ID and pass the first element. If we don't do the first, again, we're going to have the same problem. We're going to get an array back. And there's not going to be any name on that array. Oh, it passes. Is it true, though? I want to see a fail now. Is it Gaffers, the name of it? Is it Gaffers? Nope. It's not Gaffers. It's Gaffer. So it's actually inserting Gaffer. Is it Sam's Club? No, it's actually Sam. So I know that it can fail, and I know that I'm testing, and this is a little different because now look, I use a let instead so that I can reuse the Hobbit. I'm going to say, I'm going to write, okay, I'm going to insert one, check that. In fact, I get that back, and then I'm going to insert another one, reusing the same variable name. Now insert Gaffer, and then I'm going to check the Gaffer in there. I could go a little more and say, hey, I want to make sure that there's 2 in there. That will work. Cool. But in this case, though, this test is not setting that, it's not checking that I'm inserting 2. It's just checking that my endpoint, my library is returning. Notice that I'm not going directly to the database anymore because that's not what I care about. What I care about is that when I call that insert on my library, that I am getting back the Hobbit. Now, one thing that I could check though, how do I know? How do I know? Okay, I'm gonna give you a challenge. Like, how do I know that the returned Hobbit comes from the database? What if I'm tricky and I just do this and I say, return Hobbit. Okay, it's returning the same Hobbit that you sent me. If I save that, it's always gonna pass because I'm checking for the name and it's the same object that I gave you. You're sending me that back. How do I know that you're not doing that? That you're just giving me back whatever object I gave you? Eric, good job. It's gonna have an ID, right? So it's got an ID. So I could check for that. I could check, oh, not only do you have the name that I gave you, but you also have an ID, and I want this ID to be defined. Is it defined? Oh, I don't remember now. To be, is it defined? I think it's defined. I'm not sure. Okay, so we're gonna do this for both. Let's say I want to make sure that it is defined. Okay. Ah, look, it fails. Now I can't trick it anymore. So let's go back and return the actual thing from the database, and it should pass. See? Now this isn't, you know, I'm sure. No, this means it's, now I know it's coming from the database. And you could tell me, well, what if someone is tricky enough and just give you an ID? No, 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 no. That you're not working with enemies, right? What you want to make sure is that the code is doing the right thing. So you're not going to assume that someone is going to go and specifically design their code to, you know, to fake your test, to make your test pass. That's not what it is. It's your own code. You're testing your own code and your team's code. The point here is that this gives me a little more security than I'm in fact getting the data from the database. I'm just preventing possible errors. Okay. Question so far. Uh, how do you see the ID? You could console log it if you want to see the ID. You could console log it here and it will show up, the Hobbit.id. Now, what you don't want to do, it's, I mean, you could do it in this case because you're inserting 1 and 2. You could check that it's 1, that the ID is 1, but that would be testing. There is a delicate balance of, there are so many things that I can test, but I don't want to test the database code. So if I check that it's specifically 1, what I'm testing now is the database incremented the IDs. That's not your problem. Database should, and no matter what the ID is, and if later they change to have the ID be a GUID or something, that would break your test, and it's not, because what you want to do is that it's the ID there that it wasn't there before. Yeah. So you could definitely console log it if you want to see it, but it's not gonna do you. That's not, so my point is, one of the, it's tricky to figure out what to test, but it's also tricky to figure out what not to test. And whenever something is out of your control and could change without changing the functionality of the application, so it's not critical. If you switch to different types of IDs, and if you were checking that the IDs, let's say 1 and 2, then you have a problem because you switch. And in fact, what you wanted to know is that it's got an ID, not that it is a 1 or that it is a 2, because that could change. So in this case, I wouldn't test for that. I would leave it at, yeah, it's actually coming from the layers because it's got an ID. Hopefully that makes sense. So how do I test that? How do I test that this is going to be failed? Well, you could say that is to be undefined. Undefined. Yeah, that would definitely. So you check that to be undefined, and it's going to tell you that in fact it is defined. Okay, so that fails. So you know that, okay, so I am actually testing that there is a value there. Cool. So there is a to be undefined there. And there are other matches you get to be null, to be whatever. So let's change this back to be defined, which is actually what we want to test. There you go. Excellent. Good question. I missed your question. Okay. All right. So let's check. Make sure that everybody's catch up to there. And I want to do a kind of a review. Q&A is more important at this point than continue to write tests, because the tests are going to look the same. They're going to be a process of I insert something, and I check that it's there. So tell me when you're done. Excellent. People still working on it. Let me. All right. So this is a code for the insert. It's just making the test pass down here, and this is the last test that we run. I can also do this. So you have the code for both, and it's basically all of it right there. Here we go. This is just destructuring the ID out of the array. So basically what you get instead in here, what you would get is a set of IDs. Let me rewrite that differently. So you get from the insert a collection of IDs that has one element in it. So I'm basically saying, grab me the ID, from the IDs bracket 0. Grab me the first element. Another way of doing it is I could say const and then destructure the ID, destructure the first element out of the array. So those are all equivalent, right? It's just the structure in the array. Maybe we don't cover that a lot, but the same way that you destructure out of an object, you can also destructure out of an array by the position. So I'm just saying grab the first position and give me a constant, call ID with it. So this is equivalent to that, equivalent to this, equivalent to just doing it in here. Let me write the other one. So they have examples of all three of them. So grabbing the ID from here, it's also basically the same. It's the same thing. Yeah. You're gonna get the whole code, right? I'm gonna zip it up and drop it. If you want it now, but just to have it in your version of the code, let me drop it in here real quick. Yeah. I should have one person working on it. All right, good. So for the afternoon project, let me show you real quick. The project for the afternoon, it's really open, really like super open. It's just telling you, hey, do you not use test-driven development? And the idea is what we did just now, right? We wrote test thinking, I wish that my API would work this way. And then I ran the code to implement that after I saw the test fail. But wrote the code, so it passed. And then I wrote another test that I wish that it would do this. I wish that it returned. Like, if you think about it, at first we didn't implement the fact that this is returning the inserted habit. It was just inserting a habit. We wrote this. I want to make sure that it inserts a habit. Okay, implemented that. Then I came back and said, I want to make sure that it's returned in the right, inserted in the right hobbit. Okay, another test. And then we said, actually, I'm going to change the functionality of this. It's not enough that it just gives me an array with the IDs. I want the code to change to give me back the inserted hobbit. And then we wrote a test first, trying to get that. And then when we saw that the system did not do it, then we went and implemented. So we're implementing features and making changes to our code and designing the way that our code is going to work. But first, we're writing the test. That's TDD. Write the test and then go and implement it. And then you're going to create a RESTful API using Node.js and Express that publishes a set of endpoints to manage a resource of your choosing. If you want to do puppies, cats, tasks, to-dos, hobbits, Smurfs, Star Wars characters, I don't care, right? Doesn't have to have resources, doesn't have to have any of that. It could be a simple resource, very simple one. The point here is to see you write a couple of tests for each endpoint, okay? And when I say manage, I'm expecting that it's going to have full CRUD operations on it. And this is very important, right? You could do this as a stretch. Adding a test database is optional because I know, again, I was talking to your TLs in the morning. I know that there's no way that it would take a lot more practice and a lot more explanation to understand, the whole idea of setting up the test database and the environments and all that. Now you could use this as an example and wire it by hand. I'm going to do another review kind of, so you have on the video how the things connect and come together on the last 5 to 10 minutes, okay? But you don't have to have that. You could use it with a single database and that's good, okay? And that's it, right? NPM test is the stuff I think is already wired for you. So if you go check out the package.json, this is already set up to run just watch. If you wanted to use a testing database, then you have to use cross-M and all that, but it's already wired for you that way. And that is it. Okay, there's nothing else, because the point of here is having you write a few tests. Okay. For the sprint challenge tomorrow, we're going to ask you to write a couple of tests per endpoint, but you could check the status code and then make another choice of what else do you want to test in addition to a status code. Status code is always good, okay, because the status code is how the server responds depending on whether you have the right data or not. Okay. Coolio. And then let's go look at the code. No auth required. No, not for this. It's just testing a single resource, whatever you want. So let's go take another super fast look at how this is working. So you have package.json, okay? Of course, we need to check. We need to make sure that we set the environment for Jest. There is a different way of doing this. So if you look at the video, you'll see another way of doing it using Jest init. This is by far a lot simpler. Just have it in here, add this key, and you're good to go. Tell it, I want you to work node mode. Now, in addition to that, we have this cross-M library that we use in order to be able to set environment variables on a particular command only. So instead of having a .env that will always set that environment variable, we don't want it that way. We want to make sure that we can switch, depending on the command that we run, we can switch only for that one command and add a particular environment variable in there. In our case, we're using cross-env to set the testing value for the db_env. And we're using that, okay? So where are we using that? Well, when we pick, if we check out the connects file, this is now a connects file over here. If you check the connects file, this testing value is because we want to work with this testing database, okay? So we have to make, now the database that we pick, we have to make it dynamic so that it picks either development or testing based on this db_env. So during testing, we could grab this database. During development, we grab the other. So this is happening, the way that we select is happening over here. Okay, on db.config now, it's going to look for that db_env, and it's going to choose the database connection based on that. Okay, this is where we pick down here. So that means that when we run our tests, we're going to be using the testing database. That's the effect. When we run any of the other commands, since we're not test setting this value, it's going to send automatically development. Now, if we deploy to Heroku, then we'd have probably a production key here. So we would need to set this environment on Heroku to be production so that Heroku picks the database based on the production, based on this value. Okay. This is not going to show up automatically on Heroku. You have to set it on the config bars. We did do a lecture. We did do a, I think we recorded it, where we deployed to Heroku with, brain is melting. Yes, it is. Quite a few things. So we did do that. We did do a lecture. There is a video too where we could probably find that video. I think someone has it. One of the TLs has that video. They shared it. You drop it on the Slack channel here. It's like 20 minutes long, and we go through that process of moving to Heroku, so you can rewatch that. Yeah, that's good. That's one. There's more than one. That's one of them. I don't know if this is the one that's 20 minutes though. There is another one that's even shorter than that we did. All right. So that's it. This is just wired up in a way that you can have a testing database, and that's the stuff that let us go and wipe out the table without any fear, because we're not touching neither the development or the production database. This is just happening on the testing. And this is also why I like having this test right here. This is the one that says, I want to make sure that I am running on my, testing environment. I want to make sure that I'm not going into the wrong environment. So my test here is checking for that. Say I want to make sure that I'm running my test through my script that is testing this environment. Just checking that this environment is set. So there is also a Tuesday after hours on deploying to Heroku. But you have the video. There are a couple. I think that one's good enough. That does the same thing. Yes, you have to set the environment variable on Heroku for production. That's on the video too. It's on the reveal bars. So locally, you probably, for things that are not, like in this case, we do have support. Remember that we have support for using the .env file. But what this is doing is overriding that functionality only for tests. Okay, that's what this is doing. Only for the test when you run it through npm test. And why I say when you run it, because you may run this, you may just do, if you have it, I don't think I have it installed. You may just do yes. That's that watch. And if you run it that way though, that environment is not going to get set. So your test is going to fail. It's going to tell you, I don't have Jest installed globally, so let me do npx. Probably not. Yeah, it's not found. So let's do like that. That test is going to fail. It's going to tell me, yeah, you thought you were running on testing, but you're not. So this is an alarm telling me, hey, I'm not running on the testing environment. I shouldn't be, doing anything weird. Cool. I want to know right away. This is going to fail. And it should fail. I want it to fail. Okay. Beautiful thing is that this is just for the server. So as soon as I try to spin up the server, it's failing right away. I haven't even had a chance to test anything else, to hit the endpoints, to hit the database, none of that. This is going to stop and tell me you're not on the testing database. Get out. Don't execute directly. Get out. Okay, let me stop this because we're not using the server. So now I'll be like, oh yeah, I shouldn't run it directly. I should probably run npm run test. npm run test. Everything is good. Everything is awesome. Everything is good when you're part of a team, right? All right, then. So go forward on test. And then for the sprint challenge tomorrow, JSON with tokens, I'm going to change it, right? So that you could use cookies if you want to, cookies and sessions instead, and write a couple of tests per endpoint. See you then. Have a good one.